Good morning, everyone. I'm Josh Adler. I'm the founding CEO of Sourcewater in Houston, Texas. Today, we're going to be talking about the energy intelligence revolution, AI, machine learning, and geospatial big data. Before we get into the subject in depth, I'd like to give a little introduction to my company, Sourcewater. We've been around since 2014. And our mission is holistic energy intelligence. So even though it says water in our name, we started with water, and we've really evolved a lot from our beginnings as the first water marketplace for the oil and gas industry. Today, Sourcewater gathers, analyzes, and visualizes proprietary omni-channel data in the upstream energy industries. We like to think it's the most advanced geospatial mapping platform to show upstream energy and water activity on the surface and in the subsurface earlier, more completely, and more accurately than any other source. We've had 13 US patents granted so far, with many more pending. I think it helps visualize what we do to look at this slide in particular. What really differentiates us is two things. First, in the lower left corner here, you see we gather all kinds of oil and gas regulatory data, and that's kind of the traditional energy intelligence business. That's what you think of. But we also gather that kind of data for water intelligence, both sourcing and disposing in ways that no one else does. But going beyond that, what really differentiates us is the wide range of data sources that we gather intelligence from. So we have an online marketplace for water. We do all kinds of advanced geoscience analysis of the subsurface, understanding where water comes from and goes to, formation by formation. We gather data from the internet using non-regulatory sources, such as scraping thousands of newspapers to find the little legal notices that tell you who's going to drill where before they ever file a permit. And then over on the right side is really the cool stuff that we're going to focus on today. We have been pioneering the use of satellite imagery, AI and machine learning analytics, and massive mobile GPS data analytics to do real-time supply chain mapping of the oil field in ways that no one has ever seen before. And we're going to get into that. In terms of the kinds of data that we gather, we're not going to read all these right now, but we have a lot of different exclusive data sets, like tracking frac and rig crews daily on a pinpoint basis, detecting well pads, detecting frac ponds and flares every day in satellite imagery, mapping all the movements of produced water from every producing lease to every commercial disposal well in Texas and other markets. We've mapped close to 2,000 water midstream pipelines. We have market prices for water and disposal. We've mapped the subsurface with all the geologic fault lines and all the true formations and depths of injection for every disposal well in Texas and New Mexico. And we're doing some even more cool advanced things that we're going to talk about toward the end of this discussion. Just to give you a quick feel for what the platform looks like, we're grabbing an area on the map here showing all the assets, oil, gas, water. We're able to see them by operator that owns them, by formation of production or injection. And we're able to show all of the business relationships for all of the oil, gas, and water flows between all these different assets for an entire company, for a region, or even asset by asset. We show these spider charts at the top of the map showing where all the water is flowing into or from each producing lease and disposing lease. Our system is used by companies in a lot of different ways. Top use cases include water midstream, disposal, and recycling oilfield services companies, water managers, procurement supply chain from E&Ps, mineral investors, all kinds of oilfield service companies, geophysicists and geoscientists, and energy investors and analysts. So now let's talk about today's topic, which is how do we use artificial intelligence and machine learning and image processing to understand the oil field supply chain in near real time. And how do we get into this in the first place? Well, if you know a little bit about Sourcewater's history, you know we started out as a marketplace, an online marketplace for water and disposal and recycling in the oil and gas industry. And so we were trying to find all of the people who might have water for sale in West Texas. And sometimes you'll see these signs by the side of the road, frac water for sale. And we found that whenever we called them, we found somebody who was really excited to list their water for sale on Sourcewater. So we were trying to figure out, how do we find all these frac ponds? And what we discovered is there are no records of them in regulatory data. Frac ponds are completely invisible to the regulators and, in fact, to the entire business of upstream oil and gas. And so we had the idea, maybe we can spot these squares of water in the desert from space using satellite imagery. This is quite a few years ago now. And so we started building these computer vision and AI machine learning systems to process high cadence imagery of the Permian Basin to try to spot just the water pits and not things that aren't oil field water pits. And so this is the type of imagery that we were looking at and basically analyzing these changes that you can see over time. Here in this image, we're seeing well pads getting built. We're seeing the lease roads get built. We're seeing the reserve pits get built and then filled up and emptied. We're seeing the frac ponds and the recycling ponds get built and then filled and then emptied. And what we did was we created deep learning systems to break down these images and understand what's happening on the ground. And so this turned into a product that we call Dirt Work Alert. We've had 10 US patents granted on it. And basically what we're doing is identifying lease activity on the ground in advance of any permit filing or rig movement. This was something that got covered pretty extensively when it first came out a few years ago. We were very proud of the articles we had in the JPT and in the Houston Chronicle. And so as we launched into offering this product to the market, basically identifying oil field construction activity before any permit filing, we found that we were getting this kind of reaction. We talked to pretty much anybody at any SPE conference you go to and say, what if we can show you who's going to drill or frac earlier and with more accuracy than a drilling permit? Everyone would say, that sounds great, but how do I know it really works? And we realized that the kind of data that we were looking at had never been seen or studied before. And so, well, we didn't really know. So we brought in an outside firm to analyze this data, and we created a very detailed study of which we combined well pads and drilling permits to analyze which predict spuds better in the Permian Basin, or how do they even relate to each other? What is the time and probability relationship between drilling permits and well pads and spuds? And no one had ever studied this before because no one ever had access to the well pad locations. And so there were a bunch of questions that we wanted to ask, and we did ask them. I'm not going to go through the entire study here because we don't really have time. But what we did was we analyzed, or the outside firm we were working with, we analyzed every single spud, every single well drilled in the entire Permian Basin in all of 2018 and 2019, over 12,000 wells. And for every single one of them, we looked at when did the well pad appear, when did the drilling permit come out, how long after did the spud occur, and were there cases where there was a well pad with no drilling permit or a drilling permit with no well pad, or neither one of them appeared or both appeared for spud. And so in analyzing that, we use satellite imagery of almost the whole Permian Basin. The blue boxes that you see here are the area that we were really analyzing. And what we discovered along the way was there are a lot of challenges with the data in this kind of study. For example, when you think about energy intelligence traditionally relying on drilling permits and wellbore data, it turns out that almost half of all of the spuds in the Railroad Commission database actually have no date associated with them at all. So we don't know when they happened. And, almost 1 in 5 Railroad Commission wellbores don't even have a location associated with them. So we really don't know if the permit or well pad locations are accurate. There's some unknown portion of permits and spuds where they exist and they have a date and they have a location, but those dates and locations might be wrong or off somewhat, and there is no way to know that. Also, a big issue that we're going to get into later is that spuds and completions are reported typically with about a 6-month lag from reality, potentially as much as a 9-month lag in both Texas and New Mexico. And so that makes it hard to get a very current study on them. And there's other issues that we get into. One of the challenges with the satellite imagery is that sometimes you've got clouds, not that much in the desert, but we can't detect something if it's under a cloud. So one crucial issue to understand is that very often the regulatory data about wellbores and about spuds and production and everything else is just off. I know people who are deep in the industry understand that, but a lot of people think you can just throw those wellbore locations on a map or those drilling permits on a map and they'll be right. They're not. They're wrong all the time. The dates are wrong, the locations are wrong by a little bit or by a lot. Production data can be really wrong. And so that's one of the key reasons why it's so important to have independent measurements of what's happening on the ground, like from satellite imagery and from GPS location data like we're doing, because it helps reality check the regulatory data, which is so often not entirely accurate or sometimes just missing. And so now let's talk about some of the results that we got from the study. First of all, we found that the patterns for well pads and permits and spuds were very closely matching, especially after we got through a number of rounds of additional machine learning training and got better and better results over time, as you can see here. And one of the things we found in particular was that you were far more likely to get an accurate prediction of a well getting drilled when you combined both drilling permits and what we call dirt work alerts, or well pad detections. They're much more accurate when you use both than when you use either one or the other. Also, we found, as you logically might expect, a drilling permit without a well pad under it is much less likely to get drilled than a drilling permit with a well pad under it. And when that well pad appears, it's going to get drilled a lot sooner. So you're not chasing dead permits or permits that aren't ever going to happen. And here you can see for all time periods, basically, well pads combined with permits was far more predictive of future drilling than permits alone. And actually, in some time periods, well pads by themselves were more predictive, even than the combination. Basically, the permits were throwing things off. Key takeaways to know about the study include, number one, we found in both Texas and New Mexico, in about 1 in 3 cases, in about 1 in 3 new wells, the well pad was built in advance of any drilling permit filing. And when that happened, it was usually a few months before the drilling permit was filed. So you really are able to predict new drilling better by pulling in satellite image well pads than by using drilling permits alone. You do see more of them sooner. But maybe just as interesting was the fact that a large portion of drilling permits, particularly in New Mexico, are either never drilled or not drilled for a long time. So if you're in a business that requires you to figure out who is going to be drilling anytime soon, you're wasting a lot of effort if you're chasing permits without also having the well pads available, because you're chasing a lot of permits that are never going to be drilled or aren't going to be drilled soon. In fact, fully half of them in New Mexico. Once you added in the well pads, it became far more accurate and predictive. We also found that the sensitivity or true positive rate of well pad detection satellite imagery was extremely high. We were detecting 95% plus of future spuds with well pads. In fact, in New Mexico, strangely, looking at the well pads in the satellite imagery was a more accurate way to predict spuds than looking at permits by themselves. You were more likely to predict a spud with a well pad than looking at a drilling permit, which is kind of surprising. Something like 7% of spuds in New Mexico didn't have a permit. And also crucially, after well pad appeared in the same location as an undrilled permit, you were much more likely to see that well get drilled, and sooner, far sooner. So now let's talk about some of the new technology frontiers we're working on. I'm going to talk about some things today that no one has ever seen before. So we haven't announced some of these things officially, but you're getting a little bit of a sneak peek on some of our latest technologies. So one of these is, you'll remember on the slide I showed back at the beginning, where we're incorporating all kinds of mobile GPS data into our satellite imagery data and combining the two in ways that we've got patents all over at this point. There's some really cool things you can do when you combine these. So one of the things we're able to do is do pinpoint detection of rig crews and frac crews across the entire Permian Basin on a daily, even an hourly basis, rather than having to wait the 6 months for a completion report to come out to know where were the fracs really happening, where were the wells really being completed. And this has a lot of really important implications for the energy intelligence business. So what we're able to do is basically on a daily or even an hourly basis, we are able to show and detect what is happening on every well pad across the entire Permian Basin, every kind of activity all the time. And so what you're seeing here is we chose a particular well pad at random, and we're showing the high res image on the right, so you can see what's happening there. And the red lines that I'm tracing over here are days on which most of the people on the site were in a rig crew. The blue lines are days in which most of the people on the site were in a frac crew. You can see the exact amount of time the drilling cycle took. You can see the exact amount of time that the completion process took. You can even see the pad cleaning people, the well clean out folks. We can see every single water truck and sand truck delivery as it happens day by day. And then we see the artificial lift getting put in later. So we're able to understand everything that's happening and alert for everything that's happening in the whole well pad life cycle. In this image, what you're seeing is a little bit different angle on the same process, but here's what this highlights. We're able to do essentially a perfect duct count by area and by operator every single day that is accurate right up to that day, which is pretty incredible because most of the industry today basically relies on algorithmic methods to determine how many wells are drilled but uncompleted and have the completions occurred. And again, that's because completion reports are typically delayed in coming out from the regulator about 6 months plus or minus a few months. And that's not necessarily real helpful when you're trying to understand exactly what is the DUC inventory for every operator, where are they going to drill next, what is the true production happening in this basin or for that operator. This gives just an incredible level of detail on the efficiency and performance of every operator, of every service company, and exactly the DUC inventory, which is so critical for understanding where is sand demand going to go next, where is water demand going to go next, where's their competition for water demand, where are all of the oilfield services for completions, which is a majority of oilfield services, where is the supply and demand for those going to move, where are the best opportunities. And one more really cool thing that I'm going to show you, we are actually able to identify the individual route movements of nearly every transport vehicle moving across the entire Permian Basin. So every water truck, saltwater truck, crude oil truck, sand truck, solid waste truck, we can see day by day by day, hour by hour, where exactly are they picking up their loads and where are they delivering their loads. So we know who's doing business with whom and how much, which leases have acreage dedications in place already, which ones are still using trucks and don't have a pipeline, which operators are generating the most truck miles and therefore kind of environmental ESG impact, and which ones are more efficient than others, who's doing business with whom and who's getting what market share geospatially and by operator on a daily basis. This is stuff that no one has ever seen before, and we're very excited about it. One last benefit of this type of analytics that I'll mention to you, and it's kind of a real practical thing if you've ever been or spent much time out in West Texas or some of the other oilfield areas, which is most driving happens on private lease roads. These lease roads are not mapped in Google or Waze or Apple Maps. And we've surveyed oilfield drivers, and the average oilfield driver says they spend about 30 minutes a day lost on lease roads. Plus, you have the problem of companies always trying to make competitive bids for water and hot oil and other types of services, and they don't really know what the distances are because there's no road information. Well, by combining the satellite imagery with the mobile tracking data, we're able to not only map every single lease road, but exactly where you should enter that road from the public road that's in Google, and exactly the most efficient route to get from well site to well site to well site, and the distance that takes, and actually serve it up in an app to give basically private lease road real-time navigation and optimization. So that's something that is just real practical for almost everybody who works out in a big oilfield area like Permian Basin. So with that, I'm going to wrap this up. Thank you so much for your time and attention. I know I moved pretty fast through a lot of this stuff, but I hope we've got a couple of minutes for questions now. And please reach out to me, josh@sourcewater.com. We're in Houston. Visit our website, www.sourcewater.com. We're going to be making some really big announcements about some of these things, including the real-time daily pinpoint frac crew tracking that has never existed in the industry before. In just a few weeks, you're getting a sneak peek of it right here. And so we'd love to talk to you more about that and everything else that we do. Thank you so much and enjoy the rest of the conference. And now hopefully we've got some time for questions.